Welcome back to another episode of Space Nuts. I am your temporary host for today, Heidi Campo, and I'm here with the wonderful, again delightful Professor Fred Watson, astronomer at large.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hi, Fred.
How are you doing, Heidi?
I'm just doing lovely here in Space City, Houston. It's actually a quite dreary evening. I think we have rain lined up all week long, but it's absolutely necessary. It's just probably not the best time with all of us grad students going into final exams. I was hoping for some sunshine to motivate us in the last few weeks.
Yeah, it can have the opposite effect. I remember when I was a student having to do exams in June when the sun was gloriously shining and you're sitting inside an examination hall. I found it easier to work when the weather was dreary, I have to say.
Oh, yeah. I think, the rain can be really good for studying. But it kind of brings your mood down. I need some sunshine to break it up. We've got straight rain this whole week. All through the weekend. We've got all week of rain. But, it's not a buzzkill or a bummer is our questions for today.
Yep.
So we have some really fun questions lined up for you, and I think we're going to just jump right on into those. So our first question of the day is from Buddy. And Buddy from Oregon asks,
Fred, could you explain the other end of angular momentum to me? I know you explain how angular momentum makes things spin faster as they compress, but what about when things expand? Does it have the exact opposite effect? Will it spread things out differently or make things want to spin different, or how does that work? And would the expansion of the universe have that reverse angular momentum, like from the Big Bang on? Could that have been what they talk about, the scaffolding of the universe? Could that be what caused it? All right, just throwing it out there. Thanks, guys. A huge fan.
Yeah, some great questions. Buddy always does. So it's true that angular momentum, it's the energy of objects spinning. If you compress an object which is spinning, it will spin more rapidly. And the classic experiment, of course, is the office chair, where sitting at an office chair, you have your legs stretched out, you spin yourself around, pull your legs in, and sure enough, you're spinning faster. I used to do that when I had an office chair in an office and really annoy people. When it was it's a common area, so that's correct. Yep, I can be annoying. I know most of the time. Actually, I think the opposite is true. If you've got something that's spinning and it expands, then it will spin more slowly. It's just the way angular momentum works. But the question whether the expansion of the universe after the Big Bang could be related to what Buddy calls a sort of reverse angular momentum, and whether that concept ties into the idea of what we call we actually call it the cosmic web, that sort of scaffolding on which the galaxies are built, forming the universe's large-scale structure. I think that's an interesting idea that you've got the universe expanding. Now, I have seen a headline recently that says that some of the things that, I didn't read the article, but I might do it for next time. Some of the things that we are mystified by about the universe today could be solved if the universe is spinning. But it's hard to imagine an object that is everything spinning. What's it spinning in relation to? Well, we don't know. But that spin, it is possible. It could be linked in the way that Buddy is describing. I should go and chase up the headline on the spinning universe and see whether it does link to the sort of cosmic scaffolding that we see, and to things like the mysteries of dark matter and dark energy, which we so poorly understand at the moment. So thank you, buddy. That's a good question, and it'll set me off on a track of investigation, which I hope might lead to some more succinct answers than the one you've had this morning.
That could be a fun article to break Andrew back into the swing of things with. Hey, Andrew, we're going to be talking about the entire universe in relationship to things we don't even understand. Good way to bring him back.
That's what we do every week.
Yeah, it's true. It's true. Well, our next question is from Scott on your side of the world. So Scott Moonsier from Sydney. He says, it appears to me that the hyperinflation of the universe in the first 10, and then he has in parentheses, negative 34 seconds can be better explained by time dilation due to the extreme gravitation experience at that time in the early universe. At the very first moment after the Big Bang, time would be virtually standing still from the outside observer. Time would then be speeding up as the expansion progressed. So for an outside observer such as us, it would appear that the universe is much younger than it is. Please explain.
Please explain's a very famous comment made by a politician a number of years ago, and it's got all kinds of connotations here in Australia, which you won't be aware of, Heidi. So please explain. Well, I will, but I can't. I'm not sure I can give the answer. But there is time dilation when we look back at the early universe, and you can measure that because you can see, for example, how long supernovae take these are exploding stars, to rise to their peak brightness and then fade away. That length of time changes. When you look in the early universe, it's actually stretched out because of time dilation. But it's not enough to give rise to this phenomenon that we call inflation. This period, exactly as Scott mentions, for about the first 10 to the minus 34 seconds after the Big Bang, the universe expanded by a colossal amount. It was, something like changed by a factor of 10 to the power 50 in a length of time like 10 to the minus 32 of a second, something we just simply cannot get our heads around. And that is necessary, not... it's necessary. The reason why we believe that happened is that otherwise you've got a real problem in the homogeneity of the universe, that basically things are more or less the same in every direction. I won't go into it now, but that's what that inflation scenario was actually introduced for, to explain that overall uniformity. So it's not an artifact of time dilation. We know it's a real phenomenon. Time dilation, as I said, does exist. It has been measured, but it's not anything like the kind of violent expansion that was necessary to give rise to a universe that looks the way it does as we see it today. Good question, though.
Very, very interesting. Our next question is from Philip and his 6-year-old son, Enrique, from Portugal. And they have a very interesting audio question that we're going to play for you here now.
Good evening. My name is Philip, and I'm here with my 6-year-old Enrique. We're sending this from Portugal. We listen to your show every night before falling asleep, and Enrique loves it. He loves space and all things cosmos. And he's been wanting to send you a question since forever now. But we didn't have a great question to ask you. But the other day, Enrique remembered something, and he thought of a question that he is curious about. So I'm going to let him do his part now.
Is the universe finite or infinite? And if it's infinite, what is it expanding into?
Okay, so that's our question. Bye-bye. Say bye, Enrique.
Bye.
Bye.
Yeah, a question like so many of the ones we get from our listeners, and this is fantastic coming from young Enrique, who's 6 years old. I wouldn't have thought of a profound question like this when I was 6 years old, because I probably didn't know what infinite meant in those days. It's a question that astrophysics and cosmology simply don't have an answer to. Is the universe finite or infinite? We know that there are horizons in the universe beyond which we cannot see. And perhaps the best known one is the cosmic microwave background radiation, which corresponds to us looking back in time to a time in which the universe was still glowing brightly and was opaque, actually. You couldn't see through it. It was an opaque fog of brilliant radiation, visible light, in fact. Now, if I put it this way, the opaqueness of the universe came to an end relatively quickly. It became transparent over a fairly short period of time. And that's what enables us to look back to see this wall of radiation, which we call the cosmic microwave background radiation. As I think I've said before, I call it the cosmic wallpaper because it's behind everything we can see in the universe. That radiation is a horizon that we can't penetrate with any of the technologies available to us today. Eventually, maybe neutrino telescopes and gravitational wave telescopes might penetrate beyond that. But at the moment, we're limited to our electromagnetic wave telescopes, and we can't see any further. So that is it's like an artificial horizon. It's like, it's not artificial in the sense that it's human-made. It's an illusion. It's like when you're on a vessel on an ocean and you look all the way around, you can see a horizon, which is the edge of the limit of your visibility. But we know the ocean goes on a long, long way beyond that. And so it's the same sort of thing. And the question is, how far beyond that does it go in terms of the universe, not the ocean, the universe? And the answer could be infinite. It could be that it is infinite. That's not ruled out by the cosmological models that we have today. Now, the idea of it expanding into something is, again, it's illusory. All we know is that it's expanding. But we also know that the shape of space changes dramatically on very large scales. And so it might not need anything to expand into. It might be an entity of its own right, which is either infinite or finite. It's easier to imagine it when it's finite, that sort of folds back on itself, and so it doesn't have to have something to expand into. Of course, you can always invoke the multi-universe theories and perhaps suggest that there are extra dimensions that we don't see. We've talked about this before, that the universe might be expanding into, but all that is not yet supported by observations. It's conjecture mostly. So, Enrique, you're asking fabulous questions. You're asking perhaps one of the most fundamental questions that astronomers can ask, along with a few like, what is the nature of time and things of that sort. But is the universe infinite? I think is a great question. Maybe as you grow up, cosmology will advance to the state where we can put an answer on it. And we can say, from the observations we can make of things like the cosmic microwave background, cosmic wallpaper, we might be able to say that there is a limit on whether it's finite or infinite. And we hope maybe we'll talk about it on Space Nuts as well.
Well, I love that question from Enrique. I remember being probably around that age, and I was laying in bed one day and my little mind was just starting to think of these big ideas, and I was trying to wrap my head around infinity. And I just remember walking out of my room and I'm like, Mom, I have a headache. And I was like, oh, my head hurts so much. And she's like, why? What's wrong? I was like, I'm thinking about infinity and it hurts my head. And I could wrap my little tiny brain around it. And so I'll say this to you, Enrique, if these are things that interest you and you would like to be somebody who helps solve these problems one day, you want to do good in school, especially with math, because math is what they are using to define these things. So do good in school, okay? All right. Our last question for the day comes from Kevin in Melbourne. And Kevin says, love the show, guys, and love sharing insights with my high school science class. Oh, I love to see it. We're going from the little kids to the older kids. So Kevin has a question about the ISS. What is the temperature on the inside of the ISS? Does it vary from the side facing the sun to the side in relative shade? Does it increase when the ISS is in full sun? And does it drop when the ISS goes behind the Earth? Does it make a lot of noise as it expands and contracts? How is the temperature maintained at a level compatible with human life? Have a great day, and thanks for the podcast.
You could probably answer this question, Heidi. You're an aficionado of human space flight. And
well, I don't know what the temperature is, but I do know that you can follow the ISS on YouTube. There's a few channels where they have live streams going, where they have some really fantastic camera angles of the ISS, and it goes straight from NASA. You can see it on the official NASA channel. So you can watch it go around the Earth, and it's I don't have this number off the top of my head. I could probably type it in really quick, but it's what, 72 times? It's 72 sunrises in a day.
It's about I think it's 17. I think you got the numbers the wrong way around. Yeah. So it's every 90 minutes. You get a sunrise, and every 90 minutes you get a sunset. So you get one of them every 45 minutes. So I think it's 17 of each that you get during the day. It's an easy calculation. I can't do it in my head. Anyway, I think in terms of this is a great question, and it's a tribute to the engineering behind the ISS that you can do this sort of thing at all. So I think the interior temperature on the ISS is about 20 degrees Celsius, maybe 21, something like that. I can't do it in my head. Oh, wait a minute. 20 is 68 degrees Fahrenheit. Is that right?
Yeah, they keep it between 64 to 79 degrees Fahrenheit.
Yeah. Yeah. So there you go. Thanks for looking that up. I hope.
And that's official NASA.
Yeah.
Careful where you get your space news.
Absolutely. That's right. So it's a sort of ambient temperature that, and that allows astronauts to work in shirt sleeves and things of that sort without overcoats on. But it's artificially controlled. So that's all governed by air conditioning units that actually heat and cool the atmosphere. Because you're absolutely right. As the spacecraft goes in and out of direct sunlight, its temperature, the amount of radiation it's feeling, varies enormously. That in itself needs to be controlled as well. So on the when it's being heated up by the sun, you've got to try and get rid of that heat into space, and there are radiators that do that. At the same time, when you're on the other side, you want to try and conserve the heat when you're on the dark side, when you're in the Earth's shadow. So this is all taken care of in the engineering. The metals that are used are ones whose expansion and contraction characteristics are very well understood, and they're built in such a way that there's a lot of self-compensation built into it, a bit like bimetallic strips and things like that when you put two different metals together with different expansion coefficients. Nevertheless, it's a really interesting question that I don't know the answer to, and I don't know whether you would, Heidi, either, whether it creaks as it warms up and cools down, whether there's a noise from the space station as it goes into the sunlight. I wouldn't mind betting there is.
I'd assume there is. I was at a talk from an astronaut a couple of years ago, and he was giving the funniest story about their ARED device, which is the exercise device they use on the spacecraft. And if you look at it, it's huge. If you guys go to your regular gym, probably one of the biggest machines in there might be something like the leg press. So this looks like that on such a larger scale. And that's because they have all these vibration mufflers built in, because they can't have these exercise devices creating a lot of vibration. So they have these dampeners built in. And there was one day where it wasn't working like it was supposed to. And the astronauts still had to get their exercise in, but they didn't want to have all this vibration rattling apart the station. And so they solved this problem with the most clever, genius thing you would think of. Can you take a guess at how they fixed this probably multi-million-dollar problem?
Oh gosh, probably bits of cardboard stuck in between.
A sock. They shoved a sock in the little squeaky spot. So, and it solved the problem and it worked just fine. And so I would assume if we're needing to fix things by sticking socks in the corners to dampen the vibrations, I think it's probably safe to guess that it probably does make little creaks and sounds as it heats up and cools down. But another interesting thing I learned this past weekend that kind of is a direct answer to Kevin's question about how does that temperature get controlled? A lot of it is just complex patterns. And Intuitive Machines, which is another company in the space industry, has recently partnered with Columbia Sportswear. And you might be thinking, well, Columbia Sportswear, what does that have to do with space? So Columbia, their patent portfolio for the technologies they put into their jackets that keep you warm in winter conditions, their patent portfolio is 500 times bigger than any of their other leading competitors. And that is technology that I can't explain or understand, or maybe I can't even look at it unless I had an NDA and was looking at those patents. But their whole thing is they want to keep hot things hot and cold things cold. And sometimes those things are right next to each other. And that's really, I think, Kevin's question is so interesting and dynamic and multifaceted. Like, it's really, hey, how do we keep people alive and comfortable up there? And the answer is it's very complicated.
Yeah, it's interesting that link is one that I never would have guessed would happen. But I'm just thinking back, to the early days of space flights, the Mercury capsules and the Gemini capsules and even Apollo. Those problems of how you maintain a comfortable environment for astronauts to work in were solved at a very early stage in the history of space flight, not on the same sort of scale as the space station, which is vast compared with these other early capsules, but nevertheless they had to deal with it. They had to work out ways of keeping the spacecraft at a comfortable temperature inside, despite the huge variations of radiation that it's feeling on the outside. So it's probably quite old technology, but it's great that it works, and it's a tribute to the ingenuity of humans when it comes to putting human beings in an environment that they were never meant to be in terms of their well-being. Maybe we were meant to be in them in terms of our exploration, but that's a different question.
I just every time we get together and talk, Fred, I'm just left with a very positive feeling about the incredibleness of human beings and what we've invented and come up with, and it makes me just, proud of our species. We have done wonderful things, and we've continued to create incredible things. I've even seen that some people have built these devices that are helping refreeze and rebuild the ice caps. And it's like, that is a fantastic invention. And it's really cool, just like these engineering breakthroughs.
Absolutely. Engineering is, it's right up there with science as one of the most important things that we can do for the well-being of our species, and long may it continue.
Absolutely. Well, thank you so much, Fred, for answering all of these questions today and enlightening us with your knowledge. You're just a wealth of fantastic information. And it has been my absolute pleasure to be a co-host with you these last few weeks. And for those of you listening, you will have Andrew back your next episode. So look forward to him, but I will be signing off for now. Fred, did you have anything else you wanted to add?
Just once again, a thank you to you, Heidi, for making Andrew's absence, I won't say a pleasure, because he'd think I was glad to see the back of him, but certainly a delight. It's been very nice to talk to you. Thanks again.
Excellent. Well, you guys can have me back anytime. And for those of you listening, wish me luck on my final exam so that I can join my place among the stars of the superstars of the engineers and people a part of this industry. And thank you so much for having me on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.